This lesson is about simplifying fractions. And I know what you're going to tell me. You already know how to do this. I get it. There's a bunch of different ways that people teach. So what I see most often is when I see 14 over 21, people say, well, 7 can divide out of both of those. So to simplify this, I can just divide 7 on the top and divide 7 on the bottom. 14 divided by 7 is 2, and 21 divided by 7 is 3. And I agree with you. That's totally fine. That's the answer. The problem is when we get to more complicated fractions now as we're getting into algebra, that doesn't always get us the simplest form. So I'm going to show you just a different way that I'd like you to start using. And here's what I would do. Factor and cancel. Basically do a factor tree, factor it all the way down, and then cancel out to make sure it's all the way simplified. On this problem, it looks pretty much the same. 14, when we factor it, it's just breaking it apart. It's saying what can multiply to get 14. Well, I know 2 times 7 is 14. I can't break apart 2 anymore because it's a prime number, and so is 7, so I'm just going to circle those. So on the top, instead of 14, next to it I'm going to write 2 times 7. I can do that because 14 is the same exact thing as 2 times 7. So now let's factor 21. Well, 21 is 3 times 7. Again, both of those are prime, so I'm just going to bring those over here. And really, it doesn't matter how you write them. You could put 7 times 3, because 3 times 7 or 7 times 3 still gets you that 21. Now that I have it all factored, I'm going to go to the cancel. Cancel basically is what number can cancel out to 1. I don't see a 1 there. Well, actually, 7 divided by 7 is really just 1. So I can cross those out. Nothing else can cross out because it has to be the same on the top and the bottom. So what's left is going to be my solution. I have a 2 left on the top and a 3 left on the bottom. And I know what you're thinking. You're thinking, that's way more work than the first time you did that problem. I agree, it looks like a little bit more work. But again, when we get to the more complicated fractions, if you don't do the factor trees, you might not simplify it all the way. So let's move on to 12 over 60. I wouldn't necessarily know the biggest number that can divide out of 12 and 60. Maybe 6? I don't know. So let's factor it. To factor 12, I know that's 3 times 4. If you're thinking 6 times 2, that'll work the same way. This 3 is prime because I can't divide it anymore, so I'm going to circle it. But the 4 I can still break apart. 4 is 2 times 2. So on the top, if I multiply 2 times 2 is 4, 4 times 3 is 12, I can rewrite this as 2 times 2 times 3, because when I multiply that out, it still is the same thing as 12. So now we need to do the same thing for 60. I see 60 as 6 times 10. But I can still break both of those apart. 6 is 3 times 2. Yes, you could put 2 times 3. It's the same thing. And 10 is 2 times 5. So I have 2 times 3, or 3 times 2. Doesn't matter because it means the same thing. Another 2, and a 5. If I multiplied all these 4 numbers out, I would still get 60. So that's my factoring. Now we need to move to cancel. What numbers can we cancel? Well, we can only cancel if it's the same exact number on the top and the bottom. 2 divided by 2 is really just 1. This 2 divided by 2 is really just 1. And 3 divided by 3 is really just 1. So all we have left is this 5. There's a catch though. A lot of people try to put 5 as the answer. But where is that 5? It's not on the top, it's on the bottom. Whatever's on the bottom has to stay on the bottom. Well, then there's nothing on top. Well, 2 divided by 2 and 3 divided by 3, all of those are really just 1. So we really do have a 1 on the top, which makes 1/5.